Let's begin our today's lecture by understanding the philosophy which is being presented by the famous equation F equals to ma. Yes, this equation was being presented by a big scientist named Newton, so it does have so many aspects which can be explained with different point of views in a brilliant way, just like as the famous writer like Shakespeare or Allama Iqbal or any other great poet has written in one verse, in one poetry, so many different meanings. Similarly, F equals to ma do have so many different meanings present inside of it. If I'll make capital F as the subject of the equation F equals to ma, it means I'm talking about the resultant force F, and this particular equation is explaining to us, this particular equation is elaborating that the resultant force is actually equals to the product of mass and acceleration. Similarly, students, if I'll make acceleration small a as a subject of the formula, then it becomes small a equals to F over m. Now, this equation is giving me the information that acceleration actually depends on the ratio of force and mass. And it is the ratio of force and mass which is responsible for acceleration in the body. So by making acceleration subject of the formula, acceleration can be elaborated or can be explained. By making the resultant force as a subject of the formula, the resultant force can be elaborated or explained. You already know the elaboration of resultant force in terms of product of mass and acceleration. But here you need to know about the elaboration of acceleration, which is actually the ratio of force and mass. So students, the ratio of force over mass in terms of SI units can be written as newtons per kilogram. There is another special equation. There is another special equation which can be deduced from F equals to ma, and that particular equation is known by the name of W equals to mg. Yes, by the name of W equals to mg. We all know that W equals to mg is actually the special case which is being obtained from F equals to ma. Yes, I can elaborate it. This is a special case which is being obtained inside the Earth's gravitational field. If a body is falling freely, if there is a negligible air resistance, if the air resistance can be ignored, if the air resistance can be removed at a certain place in a certain apparatus, then the resultant force which is acting on the body, which is falling freely, is equals to the weight of the body. So if weight of the body is playing a role of the resultant force, then that particular weight of the body is actually equals to mass and actually equals to product of the mass and acceleration. Since this particular acceleration is the acceleration provided by the Earth's gravitational field, this particular acceleration is being named as acceleration due to gravity. So that's why this acceleration has a special symbol, which is small g. So small g is the symbol which is used in place of acceleration or the acceleration due to gravity. So I am trying to say that this particular equation is actually be obtained as a special consequence of F equals to ma. From F equals to ma, W equals to mg can be obtained in a case where the body is falling under the influence of its own weight inside the gravitational field. And at the present moment, we are dealing with the gravitational field of Earth. So resultant force is capital W, which is the weight of the body, and that is equals to the product of mass and acceleration. Acceleration due to gravity's symbol is small g, so I have used small g in place of a, so it becomes W equals to mg. So actually, bacho, W equals to mg is a special case of F equals to ma. I can come from the root of F equals to ma. This root is route, root. I can come from the root of F equals to ma. I can come from the root of W equals to mg. I can come from the root of acceleration equals to F over m, but from all those roots, we can prove that meter per second square is actually equals to newtons per kilogram. So these are the newtons per kilogram which are responsible for producing acceleration in the body. Please listen it carefully. I'm trying to say acceleration does not depend only on newtons, only on force. Acceleration does not depend only on mass, only on kilograms, but actually acceleration depends on the ratio Newton per kilogram. So how many newtons are acting per kilogram of the body are going to decide what kind of acceleration will be produced in the body. So that's why inside the Earth's gravitational field, every body do accelerate with the same acceleration of 10 meters per second square, because actually the Earth is exerting on every 1 kilogram of every body, the force equals to 10 newtons. I repeat, beta. It was being defined in your O-level studies that gravitational field strength is actually the number of newtons, the amount of newton per kilogram, which is being exerted by the bodies like Earth. So our Earth has a gravitational field strength which is approximately equals to 10 newtons per kilogram. You can take it 9.81 newtons per kilogram, or whatever is the value suggested in your syllabus. Just suppose the suggested value is 10 newtons. So I'm trying to say that Earth is exerting on every body's 1 kilogram mass. Earth is exerting on 1 kilogram mass of every body the force which is actually equals to 10 newtons. So that's why every body, whether that particular body is of the mass of 1,000 kilograms or whether that particular body is of the mass of 1 kilogram, on every kilogram, if the applied force by the Earth is same, on 1 kilogram, obviously 10 Newton of force will be applied. On a 1,000 kilogram body, obviously the 10,000 Newton force will be applied, which is going to be distributed uniformly equals to 1 newtons on every kilogram of the body of 1,000 kilograms. That's why both bodies are going to be accelerated with the same rate of 10 meters per second square. So remember, bacho, whether a body is accelerating in our daily life, a moving vehicle, or whether a body is accelerating under the influence of the Earth's gravitational field, in case of all accelerations, actually the acceleration depends on Newton per kilogram. Now our next article, according to your syllabus of A levels, is describe and explain motion due to a uniform velocity in one direction and a uniform acceleration in a perpendicular direction. Yes, well, this article belongs to projectile motion. I'm going to deal this article later on in my lecture. First, I think you people need to revise the concept of terminal velocity. The concept that the body is falling with air resistance inside the Earth's gravitational field. So that particular concept, which is famously known by the term terminal velocity, is our first article of today's lecture, falling with air resistance. So every body which is falling under the influence of the Earth's gravitational field, but air resistance is significant there. Air resistance cannot be ignored in that particular case. Air resistance is not being removed by the help of a particular kind of apparatus. So if air resistance is there, then the body definitely has to reach to its terminal velocity after covering an appropriate vertical height. So let's consider a paratrooper which is falling under the influence of the Earth's gravitational field. In our considered example of today's lecture is that paratrooper's mass along with all the accessories he contains is equals to 85 kilograms. So if 85 kilogram is the mass which is being carried by a paratrooper, equipment included, then it clearly means that 850 newtons of force, if I'll consider the value of Earth's gravitational field strength equals to 10, if I'll consider the value of acceleration due to gravity equals to 10, then it means 85 kilogram of mass will be acted upon by a force of 850 newtons on it when it is falling under the influence of the Earth's gravitational field. So beta, 850 newtons will be the initial force at the time of jump when the paratrooper has just jumped vertically downwards. Initially, the paratrooper was moving in the horizontal direction inside the helicopter, suppose, but at that time, the paratrooper do have the horizontal velocity present into it. As far as the vertical velocity is concerned, it was equals to zero because it has not started its vertical journey. The paratrooper still has not dived from the helicopter. The moment it is going to dive from the helicopter, now it has to fall vertically downwards towards the surface of the Earth. So it means now its velocity or speed is going to jump up from the value 0. Initially, the speed of the object, the speed of the paratrooper is equals to 0 in the vertical direction. So that's why initially there is no amount of air resistance which is acting on the body because it is just going to start its motion. We have started our stopwatch at that particular point when the paratrooper has dived vertically downwards towards the surface of the Earth. So initially, the speed of the object, the speed of the paratrooper is 0. It means the air resistance, which always opposes the direction of movement. The direction of movement is gonna happen in the downward direction towards the center of the Earth. So it means air resistance has to oppose in the upward direction, exactly opposite at an angle of 180 degree to the movement, to the motion, which will be downwards, onwards. So air resistance is 0, 0 air resistance in the upward direction, 850 newton of force is acting in the downward direction. It means 850 newtons are gonna play the role of the resultant force which is acting on the body. Overall, the resultant force will be equals to 850 newtons. So that particular 850 newtons actually corresponding to 85 kilograms of mass. So it means initially the value of acceleration will be equals to 10 meters per second square, according to W equals to mg or according to F equals to ma. Initially, in the initial moments of vertical displacement, in the initial moments of vertical distance covered, the body do travel with a velocity, the body do travel in the downward direction with an acceleration of 10 meters per second square. But now consider those moments of time when the vertical displacement now not remained 0. Now the vertical displacement is jumped up. Vertical speed, I'm trying to say, the vertical speed which was initially equals to 0 when the paratrooper has jumped outside the helicopter, and now that vertical speed remained or becomes non-zero. It jumps up from 0, 0.1, 0.2, 0.3, 0.5. A time arrives when it goes to 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second. So you can clearly see that the speed in the vertical direction is now increasing, becoming larger and larger than 0. The moment it increases, air resistance also does not remain zero. Air resistance also starts increasing because now the particles of air, the molecules of air starts dragging with the surface of the paratrooper, whatever is he wearing, whatever is his surface area. Remember, in the initial moments of time, the parachute is not being opened, the parachute is not being released, the parachute is not being inflated. So, person is falling down, speed upward, downward speed is increasing, because of which the vertical speed is increasing, because of which the upward air resistance is also increasing. Now, the downward force, which is actually due to the mass of 85 kilograms, is still equals to 850 newtons, while the upward air resistance starts increasing, and a time arrives when it becomes equals to 1 newtons. So 850 newtons in the downward direction, 1 newton in the upward direction. I repeat, Bacho, please listen it carefully. 850 newtons in the downward direction, while 1 newton in the upward direction. It clearly means that the resultant force becomes equals to 849 newtons. So when the air resistance becomes equals to 849 newtons, it means the resultant force, according to F equals to ma, is decreased. In F, we all know that F is the resultant force. So resultant force is decreased from 850 newtons to 849 newtons. So if the resultant force is decreased, then it means for the constant mass, the acceleration also has to decrease. So acceleration must be decreased compared with the value of 10 meters per second square. Here the values are being considered by considering the exact value of small g or the recommended value of small g, which is being recommended in your A-level syllabus and which is actually equals to 9.81. So according to 9.81, the force in the downward direction will be equals to 833 newtons. And in the initial moment of time, now you know that there is 0 newtons of force in the upward direction. That's why in the initial moment of time, the resultant is being taken as 833 newtons, while the acceleration also equals to 9.81. As the time is passing by, I have stated you people, I have told you people, I have taught you people that as soon as the body is falling in the downward direction or as soon as the body is falling vertically downwards, due to the drag of the particles of air, the air resistance starts increasing or starts increasing from zero in the upward direction. Now, this is the moment of time which is being considered at which the air resistance is increasing further and jumped up and goes to 350 newtons because acceleration is there. Acceleration means the downward velocity is going to be increased. If the downward velocity is increasing, then definitely the air resistance in the upward direction needs to increase because air resistance depends on so many different factors, but two factors out of all those are very, very important, are extremely important. What are these two factors? The one factor is the speed of the object. The more the speed increases, the more the resistance or air resistance also increases because more molecules per second do drag with the body of the moving, with the moving body, do drag with the moving body, do drag with the surface of the moving body. So this is the moment of time which is being taken in such a way that at that moment of time, the downward mass is fixed. So that's why the downward force 833 newtons is fixed, which is being obtained by multiplying 85 kilogram with 9.8 meters per second square. So 833 newton is the downward force, 350 newtons is the upward air resistance. You can clearly see when we subtract 350 from 833, it means the resultant force will be decreased. If the resultant force will be decreased, it means acceleration will also be decreased. And this acceleration keeps on decreasing. Remember, acceleration is decreasing, not the velocity or speed is decreasing. Acceleration is still being decreased. So if the acceleration is decreasing, then it means for the first stage of the movement, we will obtain the graph. Initially, the first line for the first stage of the movement, initially the first line, and this particular line is now curved, and its gradient is clearly showing. The gradient of this curve is clearly showing that the acceleration is decreasing. We all know in case of speed time graph, the gradient do play a role of acceleration. In case of a speed time graph, we can prove by calculating from the formula y2 minus y1 over x2 minus x1 that the gradient of speed time graph stands for acceleration. So if it is an acceleration, you people can see that initially for the initial moments of time, this is almost a straight line because initially the value of air resistance was ignorable. The value of air resistance can be ignored. The value of air resistance can be considered as a negligible air resistance. So in the initial moments of time, the value of air resistance will be ignored. Then it means the whole resultant force is actually the downward weight of the falling body. So if the whole resultant force is made up equals to 833 newtons in our present considered case, then it means initially the value of acceleration will also be constant, that is equals to 9.8 meters per second square up to the second or third second. You can notice the values of seconds on the x-axis. You can notice the values of speed in terms of meters per second on the y-axis. Then later on, the curve is being turned. The gradient is being turned. The gradient does not remain as a straight line. Straight line gradient means uniform acceleration. Constant acceleration of 9.8 meters per second square, or in case of O-level studies, you people used to consider it equals to 10 meters per second square. So whatever was this value, whether it is being considered as 10 meters per second square or it is being considered as 9.8 meters per second square, it remained constant in the initial moments of the journey. So that's why the graph comes out equals to straight line. Then onwards, as the time passes by, the value of air resistance becomes significant. And when the value of air resistance becomes significant, it clearly means, it does mean that after subtracting air resistance from the 833 newtons or 850 newtons, the resultant force will be decreased. When the value of air resistance becomes significant in the upward direction, as an example, when the value of air resistance becomes equals to 350 newtons in the upward direction, 350, 300 newtons, 250 newtons, 250, 251, 252, 253, 254, because the value of air resistance is increasing in the upward direction since the body is accelerating in the downward direction, which means its speed is increasing in the downward direction, which means the value of air resistance or the value of the drag of the molecules of air with the surface of the body will be increased. Now, air resistance needs to be subtracted from the value of 833 newtons, which is the weight of the body in the downward direction actually. It means the resultant force is decreased. So according to F equals to ma, if resultant force will be decreased, then with constant mass, acceleration will also be decreased. And we all know from our O-level syllabus knowledge that the particular graph of decreasing gradient in case of speed time graph shows the decreasing acceleration actually is being made in this manner. So graph is being curved in a decreasing gradient manner, means the value of acceleration is decreasing from 10 to 9, 9 to 8, 8 to 7, 7 to 6, 5, 4, 3, 2, 1. And finally, this particular acceleration becomes equals to 0. That was the moment of time when the value of air resistance in the upward direction also becomes equals to 833 newtons. The value of the weight in the downward direction is 833 newtons, and the value of air resistance increasing slowly and gradually or increasing gradually also becomes equals to 833 newtons. Now 833 newtons is the weight acting on the body in the downward direction. 833 newtons is the value of air resistance acting on the body in the upward direction. Both are being balanced with each other. Both has balanced each other. Both has cancelled each other. So it means the resultant force becomes equals to zero. And F equals to ma or W equals to mg has stated us that if the resultant force becomes equals to zero, if the resultant force of F equals to ma, if the resultant force of F becomes equals to zero because of driving forces minus frictional forces, because the driving forces and frictional forces has balanced each other, are opposing each other in the opposite directions, so cancel out each other. So it clearly means the resultant force. And when the resultant force becomes equals to zero, beta, remember, acceleration also becomes equals to zero. And zero acceleration means body starts falling down vertically with a constant velocity. Now there is no further increase or decrease of velocity. Now there is no positive acceleration or negative acceleration present in the body, present in the falling body. And that particular speed, in our present considered case, whatever is this, is equals to 50 meters per second. So this particular constant speed was being named by us in our O-level studies as the terminal velocity or the terminal speed. This whole movement is in one direction. We are considering the direction of vertically downwards direction. So that's why here talking about speed or talking about velocity are almost the same things. Now there arrives a moment of time. At that particular point of time, at that particular moment of time, if I'm not mistaken, this particular time is the time of 20 seconds. So at that 20 seconds of time, the parachute by the paratrooper is being opened. And the moment parachute is going to be opened by the paratrooper, its surface area, the overall surface area of the same mass of 85 kilograms, the surface area of the body having a mass of 85 kilogram is largely being increased. Remember, I said there are two factors which are very important for the calculation of air resistance, for the value of air resistance. Factor number one is the speed of the body. If the speed becomes larger, then the air resistance, value of air resistance also becomes larger. Similarly, if the surface area of the body is being increased, then the value of air resistance is also being increased. So you people can clearly see that at that particular point of time, which is 20 seconds in our considered case, the parachute by the paratrooper is being opened up. When the parachute is being opened up, it clearly means the surface area of the body of 833 kilograms is being increased. Of 850 kilograms is being increased. The mass is fixed, 850 kilograms. 85 kilograms, sorry. The mass is 85 kilograms. I repeat, the mass is 85 kilograms. If we multiply 85 with 10, then its weight comes out equals to 850 newtons. If we multiply 85 kilograms with 9.8, then its weight comes out equals to 833 newtons. So whether you people are considering the weight equals to 850 newtons or 833 newtons, now the air resistance, which was actually becomes equals to 850 newtons in the 19th second. In the 19th second, you people can notice that the air resistance was also equals to 850 newtons. The weight of the falling body was also equals to 850 newtons. So now, when the parachute is being opened up, surface area is increased. The value of the air resistance is largely being increased in the upward direction. And now you can clearly see, according to driving forces minus frictional forces, the resultant force becomes negative. Or I want to say, the resultant force becomes opposite to the direction of movement. The body is falling vertically downwards, but the resultant force now is acting in the backward direction. It gives the effect to the paratrooper, the effect of the braking. It is going to give the effect of braking to the falling paratrooper. Braking means decrease of speed, because negative force minus F equals to ma actually will give us the retardation. When a becomes negative, if I'll take that a toward on the right hand side of the equation F equals to ma, if I'll take that negative sign, minus F equals to ma, the force becomes negative. That's why the deceleration starts starts to be produced. That's why the deacceleration is being produced. When the resultant force becomes negative, the deacceleration is being produced. So I can write it as minus of F equals to m into minus of a. So on both sides there is a negative sign. The minus F sign is representing actually the force, the direct is representing or is giving us the information that the resultant force is acting in the backward direction, in the opposite direction to the direction of the movement. And negative sign with small a is representing actually that retardation is being produced, deacceleration is being produced. So beta, upward air resistance jumped up from 850 newtons to some other large value, as an example 2000 newtons. So air resistance becomes 2000 newtons. Suppose the downward weight is equals to 850 newtons. It means the resultant force is now playing the role of, or is producing retardation in the body, is decreasing the speed of the body, is playing the role of a braking force. And now it becomes the braking force. So because of that particular braking force, you can clearly see that this data is proving, the data of the graph is proving that the velocity is decreasing. So in a blink of an eye, in a very sharp moment of time, in a fraction of a second, you people can see that the velocity is fallen down from 50 towards approximately 8 meters per second, or you can calculate it exactly what is the value from the graph. So beta, speed starts decreasing from this moment of time. At this moment of time, speed starts decreasing because the resultant force becomes negative. Because of it, acceleration becomes negative, which is called deacceleration or retardation, which is producing the decrease of speed in the body. Now, the decrease of speed with the passage of time, or in a moment of time, the decrease of speed is also causing the decrease of the value of air resistance, which was jumped up at 2000 newtons when the parachute was being opened up. At that moment of time, the parachute was opened up, so it was being jumped up to an imaginary value, to a supposed value of 2000 Newton. So now this post value is once again going to be decreased from 2000 newtons to 1900 newtons, 1800 newtons, 1700 newtons, 1600 newtons. Why is it decreasing? Because the speed is decreasing. And we know if the speed will be increased, the air resistance will be increased. If the speed will be decreased, the air resistance will be decreased. So now the speed is decreasing. It means air resistance is decreasing from 2000 newtons to 1500 newtons to 1400, 1300, 1200, 1100, 1000, and the time arrives when once again this particular and the time arrives when once again this particular value of upward resistance becomes equals to the downward weight, which was 850 newtons. At that particular time, once again the body starts falling with the constant velocity. You people can clearly see from the graph. This is the constant velocity. But you people can see that this constant velocity is much smaller as compared to the 50 meter per second. That constant speed was 50 meter per second. but that constant speed is much smaller than 50 meter per second. So with that constant speed, the paratrooper can comfortably land on the earth at that particular moment of time. So this is the whole journey which is being read by you people under the article of terminal velocity in your O levels syllabus. And now you need to revise it in your A level syllabus.